Hi, and welcome to this video on the 20 question 2 of paper 1 of the 2020 Ordinary Level Leaving Cert Maths, which is a mouthful. Okay, so I'm going to get started up here with the pen working. For some reason it defaults to red. If you want to copy these notes, just send me an email at shanetroy@gmail.com. Okay, and hopefully you have had a go at the question, or feel free to pause it and just see, can you do it? Okay, and if you can, happy days. If not, let's see if we can provide a strategy to get it done. So in question 2 here, there's 10 marks for part A. Now I've looked ahead, there's actually a part A and B. Okay, so this is an algebraic equation, and it looks really heavy, and it's basically algebraic fractions. But you can treat this just as if it was a half is equal to, what? Let's even say a third plus a quarter. And then if you follow the method for how to do this, how to even add these two here, okay, you can get part of the way done. So one way is to find common denominators. Or a simpler way might be to multiply across by a common denominator, which might be the most effective strategy. And there's no right or wrong. Just some ways are more elegant than others, so whatever suits you best. And this is the kind of question you should have prepped. So it probably will come up, and you should just like, in a sense, this whole question is like, oh yeah, it came up. Just do. Okay, so that's your algebra needs to be a fairly decent level. So if I look here, what's a common denominator? Okay, for all these numbers. It doesn't matter what it is, as long as they all treat and divide into it. I can think of 12. Okay, so I'm going to multiply everything by 12. And in, I suppose, algebra, as long as you're consistent, if I do something to one term, so if I multiply this by 12, I'm okay as long as I multiply every single term by 12. Okay. Now by doing that, then I end up almost creating problems for myself. Okay, like I can go here, well, I can simplify it a little bit. The 2 and the 12 there goes 6 times. Okay, so I've gotten rid of the 2. Okay, so 6 times 9x minus 6. And let's use brackets instead. Okay, I'm going to get rid of the x there. Now, there's 3 to the 12. That'll simplify. So you multiply that by 4. So 4 times 3x minus 14. It doesn't matter if the 3 is at the front or back, as long as I know what I'm doing. It's really all that matters. Then the 4 into 12 here will simplify to give 3. Okay, so it's plus 3 times 9x. So I've gotten rid of all these numbers in the bottom. So like, I mean, I'm definitely at the 4 marks. Now we just need to remove brackets. So if you see brackets and don't know what to do, remove them. Remove by multiplication. Okay. So 6 nines is, 18. It's been a long day. 18 by 3, 3 is 24, 54. I should check my calculator because it's the kind of calculators I can mess up. Plus by minus is minus 6 sixes is 36. That's the first bracket removed. Then this bracket here on the second term, 4 times 3x is 12x. 4 times, now plus by minus is minus. 4 times 14 is 28 by 2, 16, 56. Again, I should be checking that on my calculator. And then this last bracket, 3 times 9 is 27x. Now, I've gotten rid of the brackets. If you see there, this is an equation of one unknown. So this is solvable. I want to bring all the x's to one side. So the 54 I leave here. I'm going to bring the 12 across. It was added on the right, becomes subtracted on the left. And the second term here was added on the right, becomes subtracted on the left. Okay, so I'm changing the operator. Now I'm going to bring this minus 36 across. So it was subtracted on the left, becomes added on the right, or positive is one way of saying it. And the 56 and minus 56 isn't moving. So everything's accounted for. It was 5 things on this step. On the next step, there's still 5 things. I've just moved them around across the equal. And if you do, their operator changes. Okay. And then now that's a calculation. Okay, so 54. No, I probably should again use my calculator. So let's learn my lesson. And 54, take away 12, take away 27. That's 15. So 54 is something, take away 12 is something, take away 27 is something, is 15 of them. It just happens to be x in this case. Now 26, take away 56 is going to be 20. Yeah, 20. I messed it up. Okay, so I'm fairly right. Now that if I can bring the 15 across, so the 15 here was multiplied on the left, it'll become divided on the far side. Okay, it won't change sign, okay, because the operator was multiplication, so the far side is division. And then x is equal to, that's what the same thing as 4 over 3. I found that by looking, is there a number that will divide evenly at top and bottom? Look, 5 is fairly obvious to me. 5 into 20 goes 4 times. 5 into 15 goes 3 times. Now, or your calculator. Now, on the next page, I should have my answer. Okay, and what have I done wrong? I know what I've done wrong. Okay, I took these away. Okay, and I got 20, not negative. Now, pretend I meant that, but unfortunately, I don't think I'm fooling anybody. So that's minus, which is that's minus, and my final answer there is minus. Okay, so look, if I made that mistake, probably would have got the brought back down to 8. Yeah, probably at the worst. Okay, but again, look, mistakes happen, and that's it there. Okay, so the next question here, part B. Now, each question in the section A is worth 25 marks. Okay, so this here is worth 15 marks. It's a huge chunk, and this is simultaneous equations. They even are nice enough to tell me. Okay, I shouldn't need to be told. I should recognize this because ultimately, this equation on top has 2 unknowns. Okay, can't solve. Can't solve an equation of more than 1 unknown. Now, the second equation also has 2 unknowns. Okay, but when comparing both equations, they have the same 2 unknowns. So I can do a trick here. If I take one of the equations, I'm going to take the simpler looking one, and I'm going to rearrange it for one of my things. Now, I think rearranging in this case, right out here, and I go, well, look, if I rearrange this for y, things might get easier, okay, than doing the other way around. So I'm going to bring the y across, okay, I'm going to bring the 4 across. I'm doing 2 things at once here. And that's the same thing as 3x, take away 4 equals, minus becomes a plus going across. So y is the same thing as 3x minus 4. Now, why is that useful? Like, I haven't solved anything here. I just have expressed one of the variables in a different way. And I could have done it with the x. Okay, I could have left the x where it is, brought the y across, okay, and then brought the 3 across, and had 4 plus y over 3. Now, to my mind, dealing with this is harder than dealing with this. Okay, but I'm just expressing the equation in different ways from the perspective of x and the perspective of y. Now, the reason I'm doing that is if I look at my second equation, okay, now it's actually an awkward one. Sometimes it's much easier. I'm not even sure what the shape of that would be. Sometimes you see this with a circle. This is linear. Okay, if this was a circle, you might be asking if it's a tangent or a chord or whatever. So whatever shape this is, doesn't matter. You're looking for where they intersect. That's ultimately what's happening. Now it's not being called out here. But in my second equation, if I take my y statement, I'm going to write them beneath. Okay. I know that y is the same thing as 3x minus 4. But I have y here as well. So if these two y's are equal, why aren't these two statements? And they are. Okay. So once I realize that fact, I can swap them. Now, if I look along, I only have one unknown. I can solve this. I mightn't want to. It's going to take me time, but I can. Okay. So if you can, you should. So 4x squared, multiply the brackets out. So first step of simplification, remove brackets. So minus by plus is minus. 3 times 3 is 9. X times x is x squared. Now I need to not forget to multiply this term by the second term of the bracket. Very common mistake. Minus by minus is plus. 3 by 4 is 12. In this case, the x carries over. And that's equal to 4. Now, if you see what's happening here, okay, I have a bit simpler. Now, I can do it a little bit better. I can combine these. So I have €4. I give 9 away. I'm short 5. Okay, plus the 12x. Now I'm going to bring the 4 across, just because I know what's happening here. But this is a quadratic. And a quadratic, if you see what's happening, it needs to be solved. The question is, can you solve it by what I call the quick method, okay, by finding the factors, okay, or will it be the quadratic formula, which we often call the minus b formula? Okay. So you can always use the minus b formula, but you may not want to because there's a quicker way. Now, I'm not sure here if there is a quicker way. This would look like an awkward one. Although, look, I'll try it. So because it's got a number in front of the x squared, you're going to have to multiply this number by this number. Now, this is the method I learned in school, so that's kind of why I do it. Okay. So minus 5 by minus 4 is plus 20. And then the middle number here, the plus 12, matters as well. So I'm looking for what two numbers will multiply to give 20, but add to give 12. Okay. Now, if you think about there, well, what will multiply? Well, 5 by 4 will. Okay. Now, 10 by 2. Okay. Probably other ones as well, 20 by 1. Now, which of them will add to give 12? Well, 5 and 4 will never add to give 12. 20 and 1 will never add. Even if they were plus or minus, it wouldn't matter. But 10 and 2, yeah, that's your baby. So my factors are, okay, 10 and 2. Now, you can write them like this. I just realized I should have changed that to a plus before I started. And if I had changed that, basically multiplying it off by a minus 1, okay, and that would give me plus 4, okay, equals 0. So we made things a little bit more awkward. 5 by 4 is 20. This is minus 12. Okay. So if these would have to be minus 10 and minus 2, my two factors. So that gives me 5x minus 10 by 5x minus 2. Okay. Equals to 0. So at that stage now, because there's an awkward minus 5 here in front, okay, you can just remove that by just the 5 and the 10 here cancel. Left at x minus 2 by 5x minus 2. Now that's a fairly hard quadratic. You can test if you're right by multiplying those two brackets out together. And you should go back to your original. Okay. But in fairness, that it might be easier there to use the minus b formula. Okay. So if you know the minus b formula, okay, you're going to be able to probably do this more effectively. Now, I have the answer on the next page. And just to point out, it was 5x squared minus 12x plus 4. It's the quadratic we're trying to solve. So the a value there, okay, is 5. The b value is minus 12, and the c value is 4. And these numbers are what's put in here. Okay. Now, that's going to take longer. You're going to get the same answer. Okay. You're going to get an answer of x is equal to, now I'll go straight to the answer here. X is equal to 2. So I left off, before I started introducing the minus b, I left off here. Okay. So you bring the minus 2, you can basically put both factors equal to 0 and find out the value of the factors. And you bring the minus 2 across, becomes plus. Now bring the minus 2 across, becomes plus, and then divide across by the 5, and you get 2/5. So there's two factors, 2 and 2/5. So whatever shape this happens to be, okay, this line is touching it at more than one point. Okay. Now we know the x values, we just found them, but we need to find the y values. Okay, so I can use the equation I came up with, or actually the one from the question is what I'm doing here. Okay, it doesn't matter which one I use. I could use this one here, and I'm going to substitute in the plus 2 for 2. Okay, there was 2 unknowns, but I know what the x value is. It's 2. I can then find out what the y value is, and then do the same thing for the 2/5. Okay, and I got this negative 2 and 4/5. Now, if I was to check this, now I don't normally do this because it'll make the video longer. And if you're, this is the last part of the question, so if you're happy out, okay, feel free to move on. Okay, but this is a nice graphing package here, and if I get into it, I can graph multiple things fairly fast. Okay, and there is something. So I should have had this ready. I wasn't going to do this, but 3x minus y equals 4. Okay, and then the second one there is 4x squared minus 3xy equals 4. Now I just realized that was a I pressed the wrong thing. So minus. Okay, so this weird looking yoke, they touch at 2 points only. That was the point 22 is one of them. I can zoom in, whatever. Okay, point 22. And this point here is 0.4 minus 2.8. Okay, so this should be what I get on the answer. You see there, 2/5 is the same thing as 0.4, and then minus 2 and 4/5 is what? Minus 2.8. Okay, which again is that. Now, the other things that matter is where this line crosses the x-axis, the x-intercept. Might be more obvious there is the y-intercept. Okay, and that can be of use. But in this question, really, this could have been phrased a different way. Now, this is a weird shape. That particular equation there is weird. Okay, sometimes you'll see that given as a circle, but it doesn't really matter what it is. Ultimately, they're just trying to test: can you apply the method of simultaneous of one of the methods for solving simultaneous equations? So leave it there. The video's gone a little bit longer than we'd liked. This is challenging, but it's 15 marks. If you can follow, even if you get lost in the maths, keep going, you'll get penalized for the error, but the rest of it will be marked as if it was correct. So if you make an error or two, you'll still be getting decent marks. Okay. Right. See you into question 3. Thanks very much.